Assalamu alaikum, my name is Mariam Tahir and my roll number is 31. Today I am here to give a presentation on the topic bistable multivibrator, which is the most important type of the multivibrator. So what is multivibrator? Multivibrator, it is an electronic instrument which is used to produce the non-sinusoidal waveform. Non-sinusoidal waveform are formed by the combination of the two sinusoidal waveform. It is containing more than one general frequency, and the non-sinusoidal waveform which is to be generating in case of the multivibrator are sine wave, rectangular wave, sawtooth wave, etc. So now, before moving towards the more detailed concept about or discussion about the bistable multivibrator, I want to tell you about some brief history about the bistable multivibrator. In 1919, John Abraham and Bloch invented the first type of the multivibrator, which is called as a plate coupled multivibrator. And this type of the multivibrator is invented with the help of the vacuum tube diodes, because nowadays, at the time in the field of the electronics, the vacuum tube diodes are to be invented only, not the PN junction diodes are to be invented very broadly at that time. So after some years, two scientists, Eccles and Jordan, also invented the first bistable multivibrator, and this was the first time that this type of the multivibrator is to be invented. And this is also called as flip flow multivibrator, because it flips and flows the two states of the bistable multivibrator by applying an external trigger pulse. So this type of the multivibrator is also to be invented with the help of the vacuum tube diodes, and the working of this bistable multivibrator is just similar like that of this first bistable multivibrator. But the only difference is that nowadays the bistable multivibrator is basically manufactured with the help of the PN junction diode rather than vacuum tube diodes, because the PN junction diode is basically more preferable as compared to the vacuum tube diodes. Now move towards the important features of the bistable multivibrator. First one most important feature of bistable multivibrator, it is basically consists of the two-stage RC coupled amplifier, means that the output of the one amplifier is basically the input of the second amplifier, and it is just like that as we have to be doing the cascaded amplifier systems. Now the second most important feature is that it is not to be using any capacitor for storing the energy elements. Only resistances are to be used instead of the capacitances for coupling network systems, and also for supplying the minus VB volt to both the bases of the Q1 and the Q2 load, in order to make the both of the loads are in the same state, that is in reverse bias state. So now the next one most important feature of the bistable multivibrator is that the bistable multivibrator is basically operated in the two modes, that is saturation mode and cutoff region mode. These two regions or the modes are basically the modes of the transistor, because as I told you that the bistable multivibrator is basically composed of the two loads, that is Q1 and Q2 loads. So the Q1 and the Q2 loads are having their working operation is lying between the saturation and the cutoff region mode. Now move towards the important feature of the bistable multivibrator is, in that case, if we want to change the states of the bistable multivibrator, because as its name indicates, bi means two, in this case we have to get the two most important permanent stable states. And if we want to change the permanent stable states, then we have to apply an external trigger pulse. And what is external trigger pulse? External trigger pulse is basically a pulse of a very higher frequency, but it is for a very short interval time, so in order to overcome the minus VB voltage which is applying to the base of both of the loads. So now the next one most important feature of bistable multivibrator is that it has no any quasi-stable state. Quasi-stable state means that the temporary stable state which is attained by any load during the charging and discharging of the capacitor. So the last one and the most important feature of the bistable multivibrator is that there is no time delay occur in the formation of the output waveform, because there is no any capacitance to be applying. When the capacitances are to be applying, then there is a time constant is to be present before during the charging and discharging of the capacitances. So there is a time occur in the formation of the output waveform in case of the monostable and stable multivibrator, in which the capacitances are to be used. This one is not to be happen in case of the bistable multivibrator, because we only use the resistances, which doesn't change its states. Now let's move towards another slide. In this slide I want to show you about the circuit diagram for the transistor working operation. There are the three main regions in which the transistor is to be operating: saturation region, cutoff region, and active region. Active region, as you have studied in the previous classes, this is the normal operation of the transistor in which the transistor is to be worked. So in this case what will happen, the meter base junction is to be kept forward bias, while the collector base junction is always to be kept reverse bias. Why the collector base junction is always to be kept reverse bias? So in order to get the large amount of the majority charge carriers from the meter side area, while when the transistor is at the saturation point, in that case the meter base junction and the collector base junction both are forward bias and the transistor is fully filled conduct. While at the cutoff region state, what will happen, both the loads of the transistor is not to be conducting, or the meter base junction and collector base junction of the transistor is basically not conducting and is in reverse bias state. Now let's move towards another slide. Okay, in this slide, this is basically the circuit diagram of the bistable multivibrator, which shows that how there will be a working of the bistable multivibrator. Before going discussion about the working of the bistable multivibrator, firstly we have to be I wanna tell you about the connections. Okay, as you can see that this is Q1 load and this is Q2 load. Okay, and this is the collector side area of the Q1 load. This is the collector side area of the Q2 load. Q1 load and this is the Q2 load. Okay, this is the we have to be using the Q1 Q2 load of the common emitter configuration of the NPN transistor. This is the NPN transistor, so that's the arrow is in downward case, same is the arrow is in the downward case, and in this case the emitter basically grounded because that's setting the common emitter configuration case. Now what will happen at the collector side, we have to be apply a resistance RC1, and from this collector side we have to be apply the resistance RC2, or sometimes these are called as the RL1 and this is the RL2, because from this side area we have to be getting the output, and from this point, that is VC1 point, or from this resistance RC1 we have to be getting the output of this Q1 load, and from this point RC2 and VC2 side area we have to be getting the output of the Q2 load. Now as you can see that this is the output of the Q1 load, and this is the output of the Q1 load, which is to be coupled to the input of the input base of the Q2 load through the resistance R2, and the output of the Q2 load is coupled to the input base of the Q1 load through resistance R1, right? So R1 and R2 basically used in order for the coupling network system instead of the capacitances used. As you can see that, as you can recall the previous concept in your mind, that in the multivibrator and in the monostable multivibrator or the astable multivibrator, here side area is to be connected with the capacitor, but in that case we have not to be using capacitor, we have to be using only resistance R1 and R2 for the coupling network system. Now this is the minus VBB volts. Okay, and another thing is that this is the collector, the same the single power supply is to be used for connecting or supplying the plus VCC voltages both to the collector of this Q2 load and the collector of this Q1 load. Why we connected this plus VCC volt? As you can see that this is the normal this is also to be done in the normal portion of the transistor. The plus VCC volt is always to be applied to the collector in order to make the collector junction reverse bias. So now what will happen now, this is the resistance R3 and this is the resistance R4. Through these two resistances we have to be apply the minus VB volt to both the bases of the Q1 load and to the bases of the Q2 load. Why we connected this minus VB volt to both the bases of the Q1 and Q2 load through resistance R3 and R4? The main purpose or the main reason is that in order to make the emitter main junction also reverse bias, because we want that because we wanted that both of the two loads Q1 and Q2 are to be remain in their same state, and always, and when we close the switch from this the switch has to be closed here already, has to be seen in the diagram. When we close the switch, then we give a path to the electron for the flow, but there will be no current is to be flow because the emitter base junction always reverse bias and collector base junction always reverse bias, until unless if we apply any trigger pulse either from this Q1 load side or either from this Q2 load side area. If we not apply any trigger pulse, then they always remain in their reverse bias state. So now we want to see it's working. So now what will happen, we have to apply this. So the main purpose of this minus VB voltage is to supply the negative voltage of this Q1 and Q2 load, and we wanted to make the both the two loads Q1 and Q2 loads are to be in reverse bias. It means that in the same state we wanted that we have that the Q1 and Q2 load both are to be remain in the same state. So now what will happen? Firstly we want to know it's working, so we have to apply firstly the trigger pulse, external positive trigger pulse we have to be applied, right? External positive trigger pulse we have to be applied from this Q1 load side area. When we apply this, now we have to be applied this capacitor C1. Why we apply this capacitor C1? The basic purpose of putting this capacitor C1 in order to remove the DC fluctuations from the AC current, because as you know that in AC current there will be some DC currents are to be present. So that's why in order to remove some DC current we have to be apply the AC capacitor, because the AC block the DC and allow the AC to pass through them. So that's why only the AC current is to be passed through this wire, or right? So now when it reaches at this junction, now what will happen? As you can see that already the minus VB voltage is applying to the base of this Q1 load. So now what will happen? If this negative voltage is already supplying to base Q1 load, so that's why we have to apply such external higher frequency positive trigger pulse. Higher frequency trigger pulse means that it its energy is to be very large. Or in terms of the electronics, the energy means that their potential, either the positive or the negative potential, to be very large. But we gave the positive potential to this trigger pulse, so it has a very high positive potential trigger pulse is to be applied. So that's why it overcomes this negative potential. So only the positive potential are to be applying to the base of this Q1 load. As you can see that we are studying the NPN transistor. So in NPN transistor, base is basically positive. So now what will happen, the meter base junction is forward bias. When a meter base junction is forward bias, then what will happen, the maximum amount of the current is to be flown through this Q1 load. When the maximum amount of the current is to be flown through this Q1 load, then what will happen at this point? Firstly, when the current is not to be conducting by the Q1 load, then this point is basically at the higher potential, means plus VCC. There will be some difference when we say about the potential and maximum potential difference. As you can notice, as you can study in the previous classes, that when there will be a current in the circuit, then there will be no potential in the circuit, but there will be a maximum potential drop occur when the current is to be flown in the circuit. And when there will be no current in the circuit, then there will be maximum potential, and when there will be a current in the circuit, then there will be a minimum potential, but there will be a maximum potential drop occur. So that's why when a current is to be flown in that area, in that point, there will be minimum potential, but the maximum potential drop occur in such a way that, as you can see that my cursor, this is a plus VCC volt. So at this point of the RC1 resistance, there is still plus VCC volt, but at this point, due to the flowing of the current, this point is basically reduced from plus VCC volt to the 0 volt. And when it is reduced to lower potential, when it reduces from plus VCC to 0 volt and becoming into the lower potential, then it gives the negative voltage, is negative sign. So now what will happen, this is become now negative sign, and maximum potential drop occur from here. So now what will happen, that this negative voltage are now supplying to the input base of this Q2 load. When it is applying to the input base of the Q2 load, as already the minus VV voltages is applying to the base of this Q2 load, then what will happen again, the more negative potential is to be applying to the base of the Q2 load, which makes the Q2 load more into the cutoff region, means that the emitter base junction is also into more reverse bias case. When it is more in reverse bias case, then there will be no current is to be flown into the circuit. When there will be no current is flown into the circuit, then there will be a maximum potential and minimum potential drop, right? So there will be a maximum potential we have to be get at this point, that is plus VCC volt, and also in that point also plus VCC volt. So that's why there will be minimum, or there will be no any potential, maximum potential drop is to be occur, because as we know that when a current is to be flowing into the circuit, then it overcomes the potential, then it reduces the potential. So that's why at this point there will be a very higher potential. Very higher potential means that there will be a positive voltage. Then what will happen, as you can see that this wire is basically coupled to the input of base of the Q1 load. So now what will happen, this positive potential now again further basically reaching to the base of the Q1 load, which makes the meter base junction more and more forward bias. When the meter base junction of this Q1 load is becoming more and more forward bias, means that the more and more large amount of the current is to be flowing into the circuit. When large amount of the current is to be flown into the circuit, then what will happen, this point is now more reduced into the 0 volt. When this point is more reduced to 0 volt, then again negative supply is to be applying to this Q2 load, and this same phenomena is to be occur, and this Q1 load is to be remain in their saturation state, and the Q2 load is to be remain in their cutoff state until unless if we disturb this system externally, or we apply any external trigger pulse, then it remains either it means in their same state. So that's why we have to be getting the two stable states. First stable state to be getting from this point, second stable state to be getting from this point, and we have to be check this, and if we are doing experiment in the laboratory, then we check the our output by plugging wire into this point, and to check the output of the Q1 load, and to check the output of this Q2 load. So in this way we have to be getting this phenomena. If we want to change the state of the Q1, we want to bring back the Q1 load into its original state. So now what will happen, now we have to applying the next external triggering pulse, but from this side area. When we're applying the next external triggering pulse from this side area, then what will happen, this Q1 load now driven towards driven from the saturation point to cutoff region, and this Q2 load now in the saturation region, and it moves the cutoff region states. The same phenomena to be happen just like in the Q1 load. What will happen, this positive trigger are to be very very large in potential as compared to minus VV, so it overcomes the minus VV volt. And now what will happen, the meter base junction is basically the forward bias, large amount of current is flown, and at this point what will happen, And at this point what will happen, there will be the reduction of the voltage or potential is to be occur, means that plus VC voltage is to be reduced into the 0 volt, and so that's my maximum potential drop is to be occur from this side area. And now what will happen, the negative voltage is now supplying to the Q1 load, which now drives the Q1 load from the saturation region or cutoff region. And now what will happen, when the negative voltage applied to the Q1 load, what will happen in meter base junction, now in that Q1 load is for reverse bias, and so that's why there will be minimum amount of the current is to be flow in that case. So that's why at this point now the potential is to be very large. So now again the positive potential is to be supplying to this, and the same phenomena are to be happen as I told you earlier. So this is the working phenomena of this. As you can see in this diagram, he takes the output from this case, and also he applies some coupling capacitor. The purpose of the coupling capacitor is also is that that it removes any DC fluctuation, either it is to be present or only the AC current signals are we getting at this side area, because as you know that nothing is 100% pure in this world. So in AC current nothing, neither we have to be completely remove the DC from the AC. So that's why he again apply the coupling capacitor, and from this case he getting output from this side area instead of this. We can also take the output from this side area, right? So now let's move towards another side. In the another slide I have told you the output waveform of this. Here in this slide this is shown that the output waveform of the bistable multivibrator. This is the output of the Q1 load, and this is the output of the Q2 load. Hopefully you see my cursor. And through this side of the base of the Q1 we have to apply the external trigger pulse, and this shows the external trigger pulse that is applied across the base of the Q2 load. So now what will happen, firstly already we have to be apply the external positive trigger pulse, so that's why we get the minimum voltage and transistors in fully filled conducting state. So that's why the transistor we can say that is in saturation mode. So when the transistor or the Q1 load is in saturation mode, then at the same time the Q2 load is basically in cutoff state mode, and so that's why it has the maximum voltages, because this graph is basically plotted between the voltage and the time. So now I wanted to bring back the Q1 load to its original state, and its original state is cutoff state. So in order to drive the Q1 load back to its cutoff state, so now what will happen, I have to apply the two conditions. First one condition is that either I have to apply the external negative trigger pulse to the base of the Q1 load, or I apply the external positive trigger pulse to the base of the Q2 load. So in this diagram as you can see that I have applied the external negative trigger pulse to the base of the Q1 load. When it applied the external negative trigger pulse to the base of the Q1 load, then what will happen, it drives the Q1 load from saturation region to its cutoff region, and making the meter base junction is to be reversed by applying the negative voltage to the base of the Q1 load. So but as you can see that there is a single pulse is to be obtained in case of the bistable multivibrator, because in that case we have to get only the two stable states of the two loads, because there is no any changing, or there is no any temporary stable states are to be occurred. Why there is large number of the signals or pulses are to be used, this is shown that when we changing our external trigger pulse by time to time, then we get these pulses. So now let's move towards the another slide. In this slide basically shows that how we basically store the binary number or the binary data by using the bistable multivibrator. So we have to be use or stores the binary data in such a way that when the basically Q1 load is in cutoff state and Q2 load is in saturation state, and both of these two load now remain in their state until unless we have to apply any external trigger pulse in order to change the states, then what will happen, the one transistor load basically shows the one binary number, and the load basically shows the another binary number. So how it shows or stores the data in such a way that when the transistor is in cutoff states, then what will happen, there is a maximum voltage are to be appear. When there is a maximum voltage are to be appear, then it is noted as the binary number 1, and when the another transistor or the same transistor Q1 load is in basically saturation mode, then what will happen, the maximum current is to be flown in the transistor, and there will be a minimum voltage, and this minimum voltage is to basically denoted by the binary number 0. Here in this video there is an animated video of how the rapid output waveform is to be generated in case of the bistable multivibrator. This is the circuit diagram of the bistable multivibrator, but the only difference in this circuit diagram is that this is the equivalent circuit diagram of the bistable multivibrator, and the total amplifier circuit system of the bistable multivibrator, in which the two Q1 and Q2 loads are to be joined with each other through coupling network systems, and it is denoted in that case by this triangular symbol. And this is the resistance R, which is basically the load resistance across which we get the output output, and this is the coupling capacitor C, across which we have to apply the external trigger pulse. So as you can see that when we apply this external trigger pulse, then we get this minimum voltage, right? And then so on, there will be a maximum voltage which shows that the either Q1 or the Q2 load is to be off. So as you can see from this animated diagram, there will be generate rapid formation of the output waveform in case of the bistable multivibrator due to the absence of the capacitances. So now let's move towards the next slide. Here in this slide there is some uses of the bistable multivibrator. First one uses, it is used in timing circuit as frequency divider, and we have to be choose the frequency of the frequency of any signal according to our requirements. And it is also used in counting circuits, as I have told you earlier, or it is also used in computer memory circuits or computer memory chips, and it's also used for storing devices and for especially for storing of binary numbers, as I have told you earlier how we have to be stored the binary number 0 and 1, which is the language of the computer. So that's why these are also used in computer. So it is used for the production of the different clock pulses, and also to use for different relay controller. And it is also used in different circuit as a toggle switch. Toggle switch means that there is a flip-flop switch, or the two states are to be obtained. So that's all from my side. I hope you like it. Thank you.